You ever feel like you're just drowning in tabs, articles, data, just desperately trying to piece together a simple, factual answer?
Oh, yeah.
You know that feeling, that huge mental burden,
Oh,
right?
yeah.
Manually sifting through search results, trying to get the facts straight.
Definitely.
Well, today we're diving headfirst into the cutting edge of how AI is trying to solve that exact problem. Welcome to the world of agentic search systems.
hmm
Think of them as your future, like, superpowered research assistants, ready to take on all that grunt work.
Indeed. And these aren't your typical keyword searches anymore, not by a long shot.
Right.
Our deep dive today is based on this really fascinating new research paper. It's called Mind2Web 2, Evaluating Agentic Search with Agent as a Judge.
Okay.
It's from The Ohio State University and Amazon AGI, and it just dropped this month, June 2025, so it's super fresh stuff.
Wow, cutting edge then.
Mm-hmm.
So our mission for you in this deep dive is basically to unpack what agentic search actually is.
Yeah,
Why evaluating these complex systems is such a massive challenge.
it really is.
How this new benchmark, Mind2Web 2, is trying to tackle it head on. And, what the latest results tell us about the huge promise and, yeah, some of the real pitfalls,
Yeah,
too.
definitely. Good and the bad.
Get ready for some, I think, some genuinely insightful moments here.
Mhm.
To really appreciate this leap forward, maybe we should first talk about the mental hurdles traditional web search created, how that's changing.
Good starting point.
For decades, right, web search has been pretty straightforward. You type in keywords, you get, what, a list of links?
Yep. 10 blue links usually.
Think back to early Google. Systems like TF-IDF figuring out relevance, PageRank voting on authority. Brilliant for their time, sure.
For sure. Groundbreaking.
But they still left you doing all the heavy lifting, manually opening links, reading pages, putting it all together. It places this huge mental burden on us.
Precisely. And that's where agentic search steps in, fundamentally changing that whole interaction model.
How so?
Well, instead of you doing all that manual clicking and reading, large language models, LLMs, they take over. This isn't just like a small step up. It's a really fundamental shift. Imagine just handing off the most tedious parts of research, the clicking, the skimming, cross-referencing.
Really annoying stuff.
Exactly. To an AI that never gets tired. It frees you up to ask the real questions, the strategic ones, because the grunt work's gone.
Right.
The paper says it autonomously browses the web, synthesizes information, and returns comprehensive citation-back answers,
Yeah.
basically offloading many low-level tasks to a tireless AI agent.
That sounds incredibly powerful, but what are the immediate trade-offs or maybe potential pitfalls when an AI can just browse and synthesize like that?
That's a great question.
Or maybe first we should clarify, what do these agentic search systems actually look like? Are they all the same?
No, not at all. They've evolved quite a bit, and we can kind of categorize them.
Okay.
First, you have what they call search-augmented LLMs. These are probably what most people are familiar with. Think ChatGPT search, Perplexity Pro search.
Right, I've used those.
Yeah. They use search APIs to get information, but the paper notes they often have a limited search horizon,
Meaning?
meaning they don't dig very wide or very deep, and their information synthesis abilities are often quite shallow. Good for quick answers, but not for really extensive research.
Got it. Quick lookups, not deep dives. So where do we go from there?
Then you have autonomous web agents. An example is OpenAI's Operator.
Okay.
These are designed to browse the real-time web, as humans do, often with visual perception.
Visual perception, like they see the web page.
Kinda, yeah. They can interpret the layout, interact with menus, forms, buttons, much more like how you or I would navigate a site.
Interesting. And then I guess the big guns for the really complex research.
Exactly. Those are the deep research systems. Examples mentioned are OpenAI Deep Research, Gemini Deep Research, Grok Deep Search, Deeper Search, and Perplexity Deep Research.
Okay, quite a few players there.
Yeah. And these are specifically optimized for long horizon browsing and search behavior. They use a whole suite of advanced tools, including search APIs and web browsing, to conduct, substantially longer horizon and deeper research.
So they combine different methods.
Right. Think of them as dedicated investigative AIs built for complex, multi-step info gathering.
Okay, so you have these incredibly sophisticated AI systems. Some browse like humans, others do deep dives. But here's the rub, isn't it? How do you even evaluate something that complex, that dynamic?
That is the core challenge the paper tackles. They call it the evaluation crisis.
An evaluation crisis sounds serious.
Well, yeah. The rapid growth and complexity of agentic search have just completely outpaced the old ways of testing.
How so?
Existing benchmarks usually assume, short search horizons and static answers, like checking a fact on one specific unchanging web page.
Right, simple stuff.
But real-world tasks are often long horizon and time-varying. Think about product catalogs that change constantly, or hotel room availability, or flight prices.
Information that's always shifting.
Exactly. So how do you rigorously evaluate an AI that might take, like the paper says, an hour and hundreds of actions across dozens of websites? How do you grade that fairly and consistently?
Wow, an hour and hundreds of actions. Yeah, that's not just a quick search. That's serious work. So Mind2Web 2 comes in to solve this evaluation crisis. What's its specific purpose?
Its purpose is to rigorously evaluate agentic search systems on realistic and long-horizon tasks involving real-time web search and browsing. It's a huge undertaking just to build such a benchmark.
And how did they even create these tasks? It sounds like it would take, well, forever.
It wasn't easy. The paper states it involved at least 1,000 hours of human labor.
1,000 hours?
Yeah, from a dedicated team of task proposers, refinement experts, and validation experts. They had to make sure every task was realistic, complex enough, but also verifiable.
That's incredible dedication. So what makes these tasks so uniquely challenging for an AI then?
Well, they have very specific characteristics. First, they're realistic and diverse. 130 tasks across domains like shopping, entertainment, science, research, careers, travel, lots of different areas, 24 subdomains in total.
Covers a lot of ground.
Second, they are long horizon and laborious. These tasks are genuinely highly time-consuming for humans. The paper says up to 1 hour to complete sometimes.
An hour for one task. Wow.
And requiring visits to, on average, as many as 38 websites and 375 web pages.
375 web pages. That's intense. It really highlights why we need AI for this stuff.
Absolutely. And critically, many tasks are also time varying. The information changes in real-time prices, stock levels, availability.
Right, the dynamic element.
And finally, each task is objective and verifiable. They have clearly defined criteria so you can check if the answer is actually correct.
Okay, so the tasks are complex, long, dynamic, but checkable. How on earth do you grade an AI's performance on something so fluid? What kind of evaluation system can keep up?
Yeah, this is where their agent as a judge framework comes in. It's a novel.
Agent as a judge. Tell me more.
Right. So because these AI answers are so complex and the info can change, standard methods just don't work. The core idea is what they call generation verification asymmetry.
Generation verification asymmetry. Okay, what does that mean in plain English?
It basically means even though the AI might generate its answer in lots of different ways, we know in advance a priori, as the paper says, exactly what specific pieces of information the task is looking for.
Ah, okay. So you know the target, even if the path to get there varies.
Exactly. And because you know the target, you can design a very specific, detailed grading rubric for that task.
Like a super detailed checklist?
Precisely. They call it a tree-structured rubric design. It breaks down the evaluation into these hierarchical nodes. And each final leaf node is just a simple binary judgment, a 0 or a 1. Pass or fail on that specific point.
Okay.
And these rubrics are seriously complex. On average, they have 50 nodes. The biggest one has 603 nodes.
600 nodes. That's incredibly granular.
It is. Think about that IKEA shopping list example they mentioned. Find specific white furniture bed frame, desk, chair, lamp, wardrobe, all from IKEA, within a budget, say $200, $600.
Okay, I can picture that task.
The rubric for just the bed frame might have leaf nodes checking. Is it white? Yes, no. 10. Is the price info correct? 10. Is it actually from IKEA? 10.
Right, very specific checks.
Then maybe an overall node for bed frame check pass. And another critical one is the total price within the budget range. All these checks form this complex tree leading to an overall score. It ensures amazing rigor.
Okay, that makes sense. It's incredibly detailed. But who or what does all this judging? It sounds like a lot of work even with the rubric.
That's the clever part, the judge agent.
Ah, another agent.
Yeah, it's a task-specific agentic workflow. Basically, it's a Python script designed specifically for that task's rubric.
Okay.
It uses LLMs in two ways. An extractor part parses the AI's answer to pull out the relevant bits of information. And a verifier part, using LLM as a judge, checks the extracted claims against the sources the AI provided, or against known facts according to the rubric rules.
So it's AI evaluating AI based on this super detailed rubric. How reliable is that?
Remarkably reliable, actually. They tested these judge agents with humans, and they achieved a 99% correctness rate.
99%. Wow.
Yeah, demonstrating their exceptional reliability. So you have AI judges validated by humans, ensuring the evaluation is accurate and consistent.
That's fascinating. Okay, so we have these incredibly detailed benchmarks, AI judges ensuring fairness. Now, let's get to the results. How did these cutting-edge agentic search systems actually perform,
Yeah.
especially compared to humans?
Right, the performance deep dive. The overall results are quite revealing. They look at two main metrics: partial completion, how much of the task criteria was satisfied, and success rate, meaning full 100% completion. What immediately jumps out is that even tasks that sound straightforward are actually pretty tedious. This led to quite low success rates. The best agents only got up to 28% full success. And even humans only managed 54%.
Only 54% for humans. Wow, so these tasks are hard even for us.
Exactly. And the gap between partial completion, which was higher, and the low success rate shows that AI often starts well, gets a lot of it right, but then struggles with the final details. Finishing perfectly is hard.
They get bogged down in the details, maybe? Or miss something small?
Seems like it. It also highlights, like you said, that humans aren't perfect either. We make mistakes on these complex, detail-heavy tasks, too.
Right, we get tired, overlook things. So how did the different types of AI systems compare against each other?
Well, the search-augmented LLMs like ChatGPT Search and Perplexity Pro Search, they were generally the weakest performers.
Why is that?
It seems to come down to their restricted search horizon and relatively shallow information synthesis abilities. They just aren't built for the kind of deep, multi-step research these tasks demand.
Okay, not their strong suit. What about the deep research systems we talked about earlier?
They were generally superior, as you might expect. These systems are explicitly designed, trained, or prompted for extensive information gathering.
Makes sense.
Many also integrate capabilities of text-only or multimodal web browsing alongside coding tools, giving them more power and flexibility.
And OpenAI's operator, the web agent, how did that do?
Interestingly, it performed lower than the top deep research systems. The paper suggests it struggles a bit with the complex and noisier environments of the real web, especially with long and more intricate context required for these tasks. Navigating perfectly for such long tasks is hard.
So being able to browse like a human doesn't automatically mean top performance on complex research?
Apparently not, at least in this comparison. The specialized deep research systems had an edge here.
We touched on this earlier, but that challenge of time-varying tasks where info like prices or availability changes, how did the AIs handle that specific dynamic aspect?
Ah, yes, this is where it gets really interesting, as the paper notes. Most agentic search systems actually perform worse on this subset of tasks
Worse. Why?
because the information is a moving target. If they rely only on search APIs that might have slightly cached or delayed data, or if they can't actively check the live website right now, they might get outdated info. This really exposes a key weakness for many systems.
Okay, that makes sense. But was there any system that did well on these?
Yes, and this is key. OpenAI operator and human participants, both of whom excel at interacting directly with live websites, actually achieved relatively on par or superior performance on time-varying tasks.
So interacting with the live site is crucial for real-time data.
Absolutely. This really highlights the importance of integrating web browsing into agentic search systems if you need accurate, up-to-the-minute information. You need to be able to check the source live.
Got it. What about efficiency versus comprehensiveness? Did the AIs that gave longer, more detailed answers perform better?
Not necessarily, which is interesting. Some deep research systems, like OpenAI's and Hugging Face's, tend to give more concise answers.
Okay.
Others, like Gemini and Grok, sometimes give substantially longer responses, often exceeding thousands of words.
Thousands of words. That's a report, not an answer.
Pretty much. But the evaluation showed that this increased length does not necessarily result in better task completion. More words doesn't equal more accuracy.
And probably harder for a human to read, too.
Exactly. The paper mentions excessively lengthy reports can be cognitively burdensome for the user. You don't want an AI essay when you have the specific question.
Makes sense. Did anything correlate with better performance then?
Time did. They saw clear performance improvements resulting from increased inference time. Basically, giving the AI more processing time often led to better, more accurate results. They can refine things more.
So speed versus quality trade-off sometimes. And how did humans fare overall in this tough test? You mentioned 54% success rate.
Right. Humans averaged a partial completion score of 0.79, which is pretty good, but the success rate was indeed 0.54, and it took us around 18 minutes per task on average.
18 minutes, so we're decent, but far from perfect.
Exactly. The paper points out we suffer from cognitive fatigue and limited working memory, especially on these tedious tasks demanding intense attention to detail. We just get tired and miss things.
Yeah, that 375th web page sounds pretty tiring. So humans get tired, overlook details. That perfectly sets us up for looking at where the AI specifically stumbles, and maybe sometimes where it surprisingly does better. Let's dig into the error analysis. What kinds of mistakes are these agentic systems making?
Okay, the errors fall into a few key categories. The first big one is simply incompleteness. The AI just didn't provide all the required information. But this has two main flavors. First, information not found. Here, the AI is actually transparent and says it couldn't find the info.
So it admits defeat.
Sort of. For example, Perplexity ProSearch apparently acknowledged it couldn't find annual global production numbers for the Mazda 3 from 2012 to 2023. Just couldn't locate it.
Okay, honesty is good. What's the other type of incompleteness?
That's partial missing. This is where the AI gives some of the info, but not all of it. Like the example of ChatGPT search providing Nobel Prize winners only from 2004 to 2014, when the request was for 2004 to 2024.
So it just stopped short, left a gap.
Exactly. Very frustrating if you needed the full range.
Definitely. Okay, what about when the AI doesn't just miss info, but gets something plain wrong, or breaks one of the task rules?
Right. That's categorized as a criteria violation. This is breaking rules or giving factually incorrect info.
Like the IKEA budget example.
Precisely. OpenAI operator suggested a furniture list totaling $12,277.97, which clearly violated the $200-$600 budget constraint in the task.
Okay, simple rule. Broken.
But here's a really striking finding. This type of error criteria violation is actually the most common error type for humans, too.
Wait, really? Humans mess up the rules most often.
Yeah, often due to oversight or carelessness, the paper suggests. We just miss a constraint or miscalculate. But get this. Some of the deep research AI systems actually surpassed humans here. They made fewer criteria violations.
Whoa. So the AI can be more meticulous about following rules than we are sometimes. That's counterintuitive, but wow.
It suggests AIs might be better at tasks requiring rigid adherence to complex constraints, where human attention might lapse.
Okay, that's a powerful insight. What about sources? Attribution is so critical for trust. How do they mess up there?
Big problems here sometimes. One error type is invalid attribution. This is essentially where the AI hallucinates links or sources.
Hallucinated links, just makes them up.
Yep. OpenAI operator, in one case, fabricated 3 links that looked like plausible Federal Reserve pages, but they didn't actually exist or led nowhere.
Yikes. That's bad. How common is that?
It's worryingly common. Even the best performing AI system on this benchmark still had a 23% hallucination rate for attribution. Others were over 50%.
Over half the links were bad.
Bad in the sense of being expired, incorrectly formatted, or fabricated. Yeah, this is a major trustworthiness hurdle that still needs serious work.
Absolutely. Making up sources is a deal breaker. What if it just forgets to give a source?
That's the next category, missing attribution. The AI makes a factual claim, but provides no citation or link to back it up.
Okay.
For instance, OpenAI Deep Research might state something about a film's director, but not link to where it found that info. The paper suggests this might happen when the AI pulls the information from its internal parametric memory.
It's training data.
Exactly. Its vast store of knowledge it was trained on, rather than retrieving it live from the web during the task, which means the info could be outdated or lack specific context.
Right. Not ideal for tasks needing current info. Okay, last category. What if it does give a source, but the answer is still wrong?
That falls under unsupported answer. The claim made isn't actually supported by the provided source, even if the source link itself is valid. And this has 2 subtypes. First is synthesis error. Here, the AI has a valid source, but it misinterprets it or extracts the information incorrectly.
Like reading comprehension errors.
Kind of. Perplexity ProSearch, for example, might look at a research paper and mistakenly identify the first author with wrong name and affiliation, or pull out inaccurate submission dates, even though the correct info is right there in the source document.
So it finds the right document but fumbles the details.
Exactly. And interestingly, the paper notes humans can make these errors too, especially when overwhelmed by large volumes of information. We misread things under pressure.
Right. Information overload affects us too. And the second type of unsupported answer?
The second is retrieval error. This is more fundamental. The source provided is completely irrelevant to the claim being made.
So the link works, but it's the wrong document entirely.
Yeah. Like ChatGPT search linking to a web page about team-up abilities in a video game when the user asked for a complete list of all abilities for a specific character. The source provided simply doesn't contain the information needed to support the answer given, making the character ability descriptions unsupported and hallucinated.
Wow. Okay. These error categories really paint a clear picture. Incompleteness, breaking rules, bad links, no links, misreading sources, wrong sources, lots of ways for things to go wrong.
Definitely. Room for improvement.
But despite all these current limitations, the paper does still talk about the immense promise of agentic search, doesn't it? It's not all doom and gloom.
Oh, absolutely not. Despite the hurdles, the potential is huge. Even now, the best AI system they tested, OpenAI Deep Research, already achieves 50–70% of human performance.
50 to 70% is pretty significant.
It is. And crucially, it does this while spending less than half the time that humans took.
Less than half the time. Okay, that's a serious efficiency gain.
Huge. And remember that point about criteria violations. For tasks requiring great attention to details and exhaustiveness, AI can actually outperform humans in some aspects because it doesn't suffer from cognitive fatigue and limited working memory the way we do.
That's the key, isn't it? We get tired, we overlook details, especially in long, tedious tasks. AI doesn't.
Precisely. It doesn't get bored or distracted checking the 300th web page. And that's where the real synergy comes in.
Partnership, not just replacement.
Exactly. The paper concludes that agentic search has substantial potential in augmenting human cognition
How?
by automating away the legwork.
Taking care of the grunt work.
Right. Allowing us to focus our limited cognitive capacity on things that matter more, such as critical decisions and oversight. It lets us operate at a higher level.
Okay, so what does this all mean for you, the listener? We've taken a pretty deep dive today into how these agentic search systems are trying to, well, revolutionize how we find and use information online.
We've seen how vital new benchmarks like Mind2Web 2 are for actually measuring their progress, warts and all.
Right, and identifying those challenges from hallucinating links, which is a big one, to just missing crucial details or getting facts wrong from sources.
And we've highlighted that while these AIs are definitely still imperfect, they already show incredible promise, especially in automating those really tedious, detail-oriented research tasks that, let's be honest, often overwhelm our human brains.
Yeah, the kind of work most of us would rather not do if we didn't have to.
Exactly.
So here's a final thought to leave you with. As these AI systems get better and better at handling the grunt work of research, the finding, the checking, the synthesizing, consider this. What new higher-level questions could you ask? What could you explore if the sheer legwork of gathering information was essentially handled for you?
Right. What new discoveries, what new insights might we unlock when human creativity and critical thinking are truly unshackled from the burden of information overload?
Something to think about.